All right, Unit 1, Retake Review, and this is on exponent rules and square roots. Now just a quick reminder, I'm going to go fairly quickly through this video. If you need to pause and just kind of think things through, go ahead and do that. All right, question number 1, we're going to simplify this expression. In this expression, there's no parentheses, there's nothing to distribute, so all we're going to do is combine like terms. My like terms are 2x squared and 3x squared because they both have x squared. Right? They have the same variable with the same exponent. So we get to add up their front numbers, a positive 2 and a positive 3, and we get 5x squared. Now I also have like terms here, negative x and positive 3x. This has a 1 here, so I'm adding negative 1 plus 3. I'm getting a positive 2x. Negative 8 doesn't have any like terms, so it just stays the same. And that's my answer. Problem number 2, we have a really simple multiplication problem here, but you got to know which rule this is. On your formula card, your formula says this: am times a to the n equals a to the m plus n. Okay, so we are multiplying our two x values, right? X times x, just like a times a. So we're going to get x, but our exponents, something else is happening, right? We see that m and n get to be added. So we're multiplying x times x, but the exponent, this 5 and this 3, actually get to be added. And so our final answer here is going to be x to the power of 8. Do not multiply 5 times 3. That will give you the wrong answer here, right? The bases are being multiplied, but their exponents are being added. Problem 3. Here, we want to combine like terms, but we cannot do that yet. We cannot do it until we have the parentheses gone. So to get rid of the parentheses, we need to distribute. Now, I don't have anything in front of this first group, so I'm going to use the number 1. All right? 1 times x is 1x. 1 times 4 is 4, right? Positive 4. My next group, I get to distribute a negative 1. Negative 1 times negative 2x is positive 2x. Negative 1 times negative 7 is going to be a positive 7. Now I can combine like terms. I've got a positive 1x and a positive 2x. I get to add those up and I get positive 3x. Okay, and then I've got a 4. Whoops. Okay, then I've got the positive 4 and the positive 7, and this is going to give me positive 11. And that's my final answer. Problem number 4, I've got this exponent outside of parentheses. The rule on your formula card looks like this: am with the n outside, and this is equal to a to the power of mn, right? And remember, no sign between these means it's really multiplication. So I know I need to multiply my exponents somewhere down here, okay? So we're going to go ahead and we're going to focus on our numbers. Everything inside of here is getting squared. So 4 is getting squared, right? That's just a regular number. But then x squared is also getting squared, and y is also getting squared. Each separate piece of this term is getting squared. Okay, so the exponents get multiplied. Now I am going to do 4 squared. We know that 4 squared, right? If you need to, I mean, you can do it in your calculator, 4 squared. But you should hopefully know that that is 16, right? So we're going to get 16. And then we have x. And our new exponent, we multiply 2 times 2 and get 4. Here there's an exponent of 1 on the y already. So I multiply the y and the 1 and the 2, and I get y to the power of 2. So my final answer here is 16x to the 4th y squared. All right, problem 5, we are looking at division. We are dividing these, which means our exponents, we have kind of a special rule for them. Let's go ahead and let's set our answer up. We have our divisor bar, and we're going to look at our regular numbers. 30 divided by 5. Nothing weird is happening here. This is a normal division with the coefficients. So 30 divided by 5 is 6. I can put a 1 on the bottom just to hold my place. And now I'm going to get into the stuff that's a little bit strange. We're going to start looking at our exponents. So I'm looking at a3 over a1. Remember, when we're dealing with exponents, we ask ourselves, where is it bigger? Right? Where is it bigger? Talking about the exponent. And the second question we ask is, by how much? Okay? So that's how we deal with exponents in division problems. Okay, so a's are bigger on the top because 3 is bigger than 1, so a goes on the top. How much bigger is 3 than 1? 2. And so that's my exponent. All right, now we're looking at our b's. All right, which is bigger, 7 or -2? Well, we know 7 is bigger than -2, so b goes on the bottom. How much bigger is 7 than -2? Well, it's 7 is positive and the 2 is negative, which means that I'm actually 9 bigger, right? 7 is 9 bigger than -2. And then we look at our c's and we notice that they're exactly the same exponent, so they cancel each other out. So my final answer here is 6a squared over b to the power of 9. All right, flip this over. We're now on problem number 6. In problem number 6, we're finding the perimeter of the rectangle shown below. We did learn this formula for a perimeter of a rectangle. That's P equals 2W plus 2L. You can definitely use that one if you want. I think an easier way to think about this is just to label all the sides, because perimeter, we add up all the sides, right? So I'm going to go ahead and I'm going to add up all of my sides. So I've got 2x plus 7 plus x minus 2 plus 2x plus 7 plus x minus 2. All right, we're going to combine like terms and then we'll be done. So 2x and 1x, let's put 1's on these x's to help our brains. And then another 2x and another 1x. So 2 plus 1 is 3, plus 2 is 5 plus 1. That's going to give me 6x. Okay? And now I can add all my regular numbers, my constants. 7 plus -2 is 5, plus 7 is 12, plus -2 is just going to be 10. So a positive 10. And that's my answer. Okay? Be really careful not to confuse problem 6 and problem 7. Problem 6, we were finding the perimeter. Problem 7, we're finding the area. Okay? And we probably should have had on here that area is equal to base times height. Right? Area is equal to base times height. So I'm going to take these two and I'm going to multiply them together. Okay? So I'm going to take 2a b to the 7th c3 times 4a to the 3rd power b squared c. Now this is the same rule that we used in problem number 2, except we just have more stuff, right? We just have more stuff. So let's just remember constants with constants, exponents with exponents, right? A's with A's. Here's what I mean. First, we're looking at 2 times 4. We know that 2 times 4 is just 8. But then we start looking at the variables, and then things can get confusing. So now I'm looking at a times a. In this case, a to the 1st times a to the 3rd. Okay, remember, when we have two bases, a times another a, we get to add up their exponents, and we're going to get 4. Same thing with b, right? B to the power of 7 is getting multiplied times b to the power of 2, so I'm going to get b to the power of, I'm going to get b to the power of 9. Okay, last but not least, I'm going to put a 1 on my c over here. We're multiplying my c's, and I'm going to get c to the power of 3 times c to the power of 1. My answer there will be c to the power of 4. Okay, and this is your perimeter for that rectangle. Sorry, area. Sorry. That's your area for that rectangle. Okay, problem 8. Problem 8, you actually already have the area. It says the area is. So I'm going to label this 21xy squared z to the 3rd power in my rectangle, because that's the area. So let's find the length if the width is 7xyz squared. So normally in an area problem like the one we just did, we would multiply things. But in this case, I don't have this other side, right? We know we're supposed to multiply this side times this side to give us the area. But we kind of, we already have the area and we don't have this other side. So we don't multiply, we divide. So I'm going to take the area, the whole big area, and I'm going to divide it by the one side I have to find the side that's missing. Okay, here we go. I'm going to set up my answer, and now we're going to start our division. All right, 21 divided by 7 we know is just 3. Put a 1 on the bottom to hold the place. We have x1 over x1, so that means they both cancel each other out. And now we're looking at our y's. Okay, my y's have y squared on the top, and on the bottom we have y to the power of 1. So it's bigger on the top by 1. And then finally we're looking at our z's, which are bigger on the top, and 3 is bigger than 2 by just 1. So my final answer here, I don't need the 1 exponents, and I don't need 1 when it's just the denominator. So that's my final answer, 3yz. All right, problem number 9. We've got an expression AB over C. It's important to notice, guys, that A and B are being multiplied and they're being divided by C. So then when they tell us what these numbers actually are, we just substitute them, okay? So A is negative 2. B is 10, so I got a 10 up there. And then they're being divided by C, which is negative 4. All we do is plug them in. Remember to multiply on the top there. We're getting negative 20 over negative 4. And my answer to this is positive 5. Problem number 10. Problem number 10, we are simplifying the expression. Here it's important to remember that we cannot add these right now because these inside numbers, the radicand numbers, have to match. Now they don't. So we got to try and simplify before we just say it can't be done. 5's prime, nothing we can do with 5, but the 20 we can mess with, right? Because we can do a factor tree. So I'm going to use 4 times 5. Circle numbers that are prime. We got 2 times 2 here. All right. So I had 3 square root of 20, but I'm going to write 20 in its prime factorization, 2 times 2 times 5. Now we look for pairs of numbers. Well, I have a pair of 2's, so 2's can be written on the outside, but remember just once. And also remember to multiply what's outside. So now I've got 6 square root of 5. 5 had to stay. It did not have a pair. Okay? Well, up here at the top, remember we were trying to add plus 2 square root of 5? And now we can actually do it, right? Because now our numbers inside are matching. I've got 5 times 5. So this is going to give me 8, right? Because we just added the 6 and the 2, but it's still going to stay square root of 5. We went through all that work to make these numbers match. They're going to stay matching. All right, so my final answer is 8 square root of 5. And then we have a bonus question. You guys need to remember that the square root of x has an exponent as a 1. And also that if there's no number written in this little weird spot, that there's no index number written, we know it is a 2. And then we follow our formula, right? M over n equals n as the index, a to the power of m. It's on your formula card. And we get x to the power of 1 over 2. Okay, that was a test question. And we do need to make sure that we know that these two expressions are actually equivalent. Okay? Make sure you are able to do all of these questions by yourself before you try to retake because your retake is extremely similar to this. Good luck.